Okay, this is the 2015 question number 5 I've been asked to do, so I'm going to put this on Canvas for you. So anyway, we got to know that this is the graph of f prime, and it says the derivative is twice differentiable, which allows me to come down immediately and see f is continuous on the interval -3 to 4 because f prime is twice differentiable. Differentiality insinuates continuous, and I put -3 to 4 because of this. And you put brackets there, it's okay. The graph of f prime has a horizontal tangent, which I've already drawn up here in the picture at those 3 places. The areas of the region bounded by the x-axis of the graph of f prime on the intervals from -2 to 1 and 1 to 4 are 9 and 12 respectively. So I'm going to put a 9 here, and since it's underneath, it's a -9. And this one is 12, and since it's underneath the x-axis, it's a -12. Find all x coordinates at which f has relative max. Give the reason for your answer. Well, for part A, I'm going to give the reason right now. Actually, I'm going to do it another time. Relative maxes occur where f prime changes sign from positive to negative. F prime changes sign from positive to negative. This is f prime, all right? So we have a positive here, and it goes negative at this place. That's a critical number. This is a critical number that goes negative to negative. So this is neither a max nor a min, and then this is an endpoint, so we don't know what happens after this. So the only place this goes from positive to negative is at -2. And if you look, it says x coordinate. So not the point, just the x coordinate. So we would say f, I'm going to answer this question right here, has a relative max at x, I'll just put it here, x equals -2 because f prime changes sign, and you got to do all of this from positive to negative at x equals -2. And you must write the at x equals -2 twice. Okay? So that's part A's done. There's all the points for that one. On what open interval contained from -3 to 4 is the graph concave down and decreasing? Okay, so concave down means that f double prime has to be less than 0. Decreasing means f prime has to be less than 0. So what I'm going to do first is, and I've already marked it up here really, f prime is negative from -2 all the way over to here, because all of these are underneath the graph. Even though that touches this graph, it does not matter. F is still decreasing. Even though just for a split instant it stops decreasing, it's still considered decreasing this whole way. So f double prime, like we talked about in class the other day, which was one of the 5 for 5 questions, f double prime is the slope of this. So I need to find where the slope's decreasing. So this slope is decreasing from here to here, okay? And then the slope is also decreasing from here to here. This is where f double prime is negative. And this over here is where f double prime is negative. So these are the 2 intervals where the graph is concave down and decreasing. So if you look, I got the decreasing stuff first, which was all this. And then I went back and did wherever this was going down to get where f double prime is less than 0. So, and this says you have to give a reason for your answer. Okay, so I would say for part B, f, and again, this says on what intervals is f both concave down and decreasing, so I'm going to start with this right here. F is both concave down and decreasing on the intervals -2 to -1 and 1 to 3 because I've got to give the reason. F prime is less than 0 and F double prime is less than 0 on those intervals. Now there is another way to say this part. And they really don't like us using F double prime because this graph is F prime. What they prefer to be put in here is that, and F prime is decreasing, which means the same as F double prime being less than 0. But by saying F prime is decreasing, I'm using the graph they gave me. So you could put in there F is decreasing on those, with this other stuff on those intervals. They prefer this one that I wrote down here in purple, but they've always counted both of these right. Part C says, find the x coordinate for all points of inflection. Now this is also one that we just did the other day that was on the 5 for 5. So we talked about points of inflection are again dealing with, and give a reason for. So points of inflection occur where F double prime changes sign. And we just talked about a minute ago that F double prime is decreasing here and here, right? Okay, I'm going to use green. F double prime is increasing here because it's the slope of this, and here because it's the slope of this. So if you look, and this is decreasing the whole way, so this doesn't change. This could all be blue if you want. So that means there's a poi at -1. Now again, notice it says x coordinate only is all I got to worry about is the x coordinate. So I'm going to come over here for part C and say F, again, I'm looking for what are the x coordinates of points of inflection for the graph F. So F has poise at x equals, and that's this bottom, this bottom one, which is at -1, and x equals 3, because that's where the slope went from decreasing to increasing, because F double prime changes sign at x equals -1 and x equals 3. And that's what you need there. Now again, do you notice that right here, I used F double prime, and we really don't have F double prime up here. So another way that they like you to write this part is they like you, instead of here, is say that F prime changes from, I got to look back up here. So it changes from decreasing to increasing. At x equals -1 and increasing to decreasing at x equals 3. They prefer this one to that because, again, this is the graph of F prime, but they always take both of these, or they have always taken both of these in the past. Okay? And then we got one more. We got this D. So D says they're giving us a point 1, 3. So the original graph of function F, the point 1, 3 is on there. Write an expression for f of x that involves an integral finding this information right here. And we want to find f of 4, and we want to find f of -2. And we know f of 1 is 3. Okay, so let's see. F of 1 is 3. Now this involves an integral. Right? Okay, so I don't know if I really like this problem very well, but we're going to do it anyway because they don't tell us where we started at 0, do they? Let's see, we know this is a positive right here, the original graph. So this is kind of a fundamental theorem of calculus thing here. So what we're going to do is we're going to say the integral from 1 to some x value of f prime of x is going to equal, dx, is going to equal some f of x minus f of 1. Okay, that's probably where I'd start. And then we would want to stick this value of 3 in for this. So we would take and put this 3 in for here. All right, now if you look, it says write an expression for f of x. So that means we're supposed to solve for this. So I would add the 3 over. So what I'm looking for is f of x, I'm going to flip this around, is going to equal the integral from 1 to x of f prime of f of x dx. And it'd probably be better to put the 3 in front, and I'll tell you why. We're going to add this 3 over here with this thing. The reason it's better to put the 3 in front is if you were by mistake to leave the dx off and you have the 3 over here, they go ahead and assume that you know the dx goes there. But if you put the plus 3 on this right side and you leave the dx off, this would be wrong, because if you left this off, what they are thinking is, and if you put the plus 3 here, they would assume that you're saying that all of this is dx, which would no longer be correct. So when you add that constant over, put that in front of the integral symbol, please. Like I have right there. So that right there is the equation they're looking for that problem number 5. Now, something else that they might want you to do, but it's not a big deal, is, if you remember, this is kind of like the other fundamental theorem of calculus. Sometimes they want you to put a different t there because of the rule of plugging this thing in, okay? But you don't have to. And I'm just going to leave it x. Okay, so now what I'm going to do is I'm going to actually find f of 4. So all I'm going to do is take this thing I just did, and I'm going to do f of 4 is going to equal 3 plus the integral of 1 to 4 of f prime of x dx. Let's see, is this this is non-calculator, isn't it? So I got to come up here and look at what they told me earlier. So you look, we're starting at 1 and we're going to 4, right? Do you remember they told me that this area was negative 12? So then I come down here and this is going to equal 3, and I plug in here the negative 12. So this answer is going to equal negative 9. So there's my f of 4. Then I'm going to go back and I'm going to plug in, what's the other one I needed? Negative 2. So what that means is I'm going to take this thing again, and now I'm finding f of negative 2, which is going to equal 3 plus 1 integral to negative 2 f prime of, actually negative 2, but we're just going to leave it x, dx. Now, what do you notice happened right here? I hope you noticed something right here. Right there, do you see they're in the wrong order?
Yeah.
You always want the smallest number below. So we're going to change that from negative 2 to 1 f of prime x dx. So when I come back up here, this is negative 9 here. So this is going to be 3 minus negative 9, which is going to end up being 3 plus 9, which would give me f of negative 2 equals 12. So did that clear up? I'm going to stop the video here. Okay, we just saw I made a mistake on C for the poi. See, we had we had a change from decrease to increase, and I came over here and did this decrease to increase, but I screwed up. There's another poi right here because this is increasing and decreasing right here at 1. So I should have also said in here that x equals 1 is another poi, and I should have had down here at x equals 1. And what I just now see is that that caused me to write this part incorrectly. Oh, I erased the part that was incorrectly. So we would have, let me erase this again. Because for both of these, the graph changes from decreasing to positive at x equals 1 and x equals -3. And then the other one is the one I left off, the 1. And that would be f prime changes from increasing to decreasing at x equals 1. So you would have, you could write this whole thing in here in place of this little thing. So I'm glad you caught that. Thank you.